Hello, my name is Philip and welcome to Chemistry Class Notes. So today we're going to be looking at empirical formula and molecular formula. So we're going to be solving around 10 or 11 questions on empirical formula, molecular formula, and also on vapor density. First of all, we should know that empirical formula is defined as the simplest formula of a compound that shows the ratio of each kind of atom in one molecule of a compound, while molecular formula is the actual formula of a compound. For example, benzene C6H6, that's the formula of benzene. That is the molecular formula, but the empirical formula is actually CH. The 6 will cancel each other. Let's answer some questions. Let's answer these questions. So, we are given an organic compound containing 60% of carbon, 13.3% hydrogen, then 26.7% oxygen. Calculate the empirical formula. We are given the atomic masses, then these are the options. So you can see that it's between carbon, hydrogen, and oxygen. So I'll just do this. So carbon is 60%, 60. Hydrogen is 13.3. Then oxygen is 26.7. So the first step here, at times you will be given their masses or in percentages. The first thing you have to divide by their atomic masses, then before you divide by the smallest for this type of questions. So remember, the atomic masses of carbon is 12, hydrogen is 1, O is 16. So I'm going to divide each of them by the atomic masses. So I'm going to do this. This is divided by 12, this is divided by 1, this is divided by 16. So when I do that, here I'm getting 5. Here I should get the same 13.3. Then here I should get 1.66. So from this stage now, we have to divide by the smallest because the ratio should be in whole numbers. So I have to divide by the smallest. So the smallest here is 1.66. So I'll divide everything by 1.66. So here, when you do this, I'm getting 3. I'll get 8. And here I'll get 1. So this C3H8O1, but we don't put the 1, we just say C3H8O. So the final answer will be C3H8O. No need to put 1. If it's more than 1, you can put it, but if it's 1, don't put 1. You leave it like that. So this is the answer, C3H8O. So your answer is B for this first question. So we're going to start with the easy questions to the a little bit complex ones. Second question, a gaseous metallic chloride MCl3 consists of 20.22% of M by mass. The formula of the chloride is, so like in every chemistry questions, you have to first of all make sure you read your question very well. Then before you know what you have to do. So we're looking up on the formula of this compound we're given. So it is MCl3, just like the first question. 20.2% of M. If you are given 20.22% of M, that means the remaining percentage, the total percentage is 100%. So you have to remove this 20.2% from 100. That will be the percentage for CL. So that's the first thing you have to do. So this is between M and CL. We're given in the question 20.22% of M. If you are given something like this in percentage, you know percentage is over 100. So the second one now here, in order to get the percentage of this compound, this atom or this element, you have to remove 20.2% from 100, which is a percent. So when you subtract 100 from 20.22, you should get 79.78. So remember the first step, when you bring it like this, the CL, you subtract 20.22 from 100, you should get 79.78. Then you do this, you follow the step, you divide by the atomic masses, then you divide by the smallest value. So the atomic masses for N you're given the question is 27, while chlorine is 35.5. When you divide, you should get this one would be 0.748, while this one will be 2.247. Then from here you divide by the smallest. This is the smallest, 0.748 divided by 0.748. When you do that, this is 1, this one is 3. So the formula is MCl3. Remember, I don't need to put 1 here because of this one. No need to put 1. Just call it as M or O, but Cl3. So your answer is 3. The carbon has an empirical formula CH and a vapor density of 39. That means molecular formula. So we are looking for the molecular formula. In order to molecular formula, you use the empirical formula. So let's see how we do this one. I also know that molecular mass is equals to 2 times vapor density. So the vapor density in the question is 39. Depending on what you are given the question, will determine the format you're going to use. You see these first two questions is different from this one, depending on what you are given. We are giving vapor density here as 39. We are giving the empirical formula as CH. We have to calculate the molar mass because it's from the molar mass we will now use to calculate N. I will now calculate the molecular formula. So this formula for molar mass is molar mass equals to 2 times vapor density. Since our vapor density is 13N, so I'll now put 39 here. That's M is equals to 2 times 39. That is 78. Then there's this formula N is equals to molar mass over formula. N is equals to mass empirical formula. So this N is the number of empirical formula units. Once you calculate N, you will now multiply it by the empirical formula to get the molecular formula. So since our molecular mass is from here is 78, I will now divide it by the empirical formula. So this molar mass is now 78 over empirical formula in question is CH. This is written as C plus. Remember, C is 12, H is 1. This is like saying 78 over 12 plus 1. That is 78 over 13. When you divide 13 into 78, you get. So after getting this N as 6, which is the number of empirical units, you will now multiply this 6 by the CH, which is the empirical formula. Molecular formula equals to N bracket empirical formula. This N is this one, which is 6. Empirical formula is CH. That is M molecular formula equals to 6 times CH. When you open the bracket, this is like saying C6 H6. When you open this bracket, this 6 multiply this carbon, and you also multiply this H, you get C6 H6. So this is now the molecular formula. In order to calculate the formula, you have to know the empirical formula. Don't forget these formulas. Depending on the question you are given, that will determine how you're going to go about it. So the answer is C6H6. C6H6 is benzene. An oxide SO2 has a vapor density of 32. What is the atomic mass of X? So since we are giving vapor density as 32, we have to remember that formula, which is molar mass equals to 2 times vapor density. So molar mass equals to 2 times 32. That should be 64. So we are giving this equation. We are giving this oxide XO2. When you are given something like this, and they ask you to calculate anything here, the first thing you have to do, you have to equate this value now, this formula, to the molecular mass. Molecular mass is the summation of the masses in a compound. So if you don't equate this to this, you cannot calculate X. But now they are saying you calculate what is the atomic mass of this X that you want to calculate. You have to you have to equate this everything here to 65, so you can calculate only X. Remember, this one is the molecular mass you calculated now. So I have to say SO2 equals to 64. This SO2 is like saying S plus O2 equals to 64. We are looking for S. We don't know S, but we know O. Oxygen has atomic mass of 16. Hydrogen is 1. Carbon is 12. Chlorine is 5.5. Some questions they will provide you with it, but other questions they will not provide you. But just know all these are constant values. It's not something you should cram. You just know it from usage. So since O is 16, so I will now put O into here. Remember these two. I mean, I'll say O times 2, that is 16 times 2. I'll put in bracket 16 times 2. So this one is 64. So S plus 16 times 2 is 30. 6 times 2 is 32. Equals to 64. Then S equals to, I'll carry this 32 to this side. It turns to minus 64 minus 32. S will be equals to 32. So your answer is B, 32. This is like the previous question. An element X forms a volatile hydride XH3 with a vapor density of 17. The relative atomic mass of S is, just like the previous question. So we are doing what we did in the previous question. The first thing is to calculate the molecular mass. Molecular mass equals to 2 times vapor density. Remember, just like the previous one, the same thing we did that we're going to do. So vapor density is 17. So I'm going to say M equals to 2 times 17. That is 35. Sorry, 34. So from here, you have to equate this compound to the molecular mass. $34. Then you split this one. This is the same thing as S plus H3 equals to 34. So you can easily find S here. Hydrogen is 1. This one you are giving 1. You know that one. 3 times 1. 3 times 1 is 3. So X plus 3 equals to 34. S equals to 34. When it comes here, it turns to minus 3. S equals to 31. So the answer is B. A compound contains 40% carbon, 67% hydrogen, 3.3% oxygen. If the compound is 180, find the molecular formula. So in this question, we first of all calculate the empirical formula. Then before we now calculate the molecular formula. So empirical formula. So we have carbon, hydrogen, and oxygen. Carbon, hydrogen, oxygen. Carbon is 40. Hydrogen is 6.7. Oxygen is 53.3. The first thing, you divide by the atomic masses. Look at them here. So carbon is divided by 12. Hydrogen is divided by 1. Oxygen is divided by 16. When you divide it, you should get 3.33. So you get 6.7. This one you should also get 3.33. So from here, divide by the smallest, which is 3.33. 3.33. 3.33. 3.33. This one is 1, this one is 1, this one is 2. So this CH2O. Remember, I don't have to put 1. CH2. This is the empirical formula. This is the empirical formula. Then from here, we calculate N. N is number of empirical formula units, which is N is equals to molar mass over empirical formula. The molar mass here is 180 over the empirical formula. So I want to just split it. This is like saying C plus H2 plus O. C is 12, H is 1, O is 16. So this 180 over 12 plus 2 times 1 is 2 plus 16. So everything here is 180 over 30 equals to 6. So since we have gotten n as 6, the next step is to multiply it molecular formula. The next step is to come back to this, then in order to get the molecular formula, because we are gotten the empirical formula first. In order to get this one, you have to, this 6, this bracket, you multiply what we have here with value. So this is like saying 6 bracket C 2 O. 6 times, that is C6, 6 times 2, H12, and 6 times O, O6. This is H12, O6. So your answer is C. Okay, 7. Organic compound empirical formula CH2 density of 45. What is the molecular? This is just the ones we've done. So as usual, since you are given paper density, first of all calculate the molecular mass, which is times paper density. This is the same thing as 2 times this 45. So the molar mass is 2 times 45 is 9. So you have to equate the let's say equate. You have to calculate n is over empirical formula. In the question, empirical formula is 2. So molar mass is 90 CH2. This is the same. I want to split this. This is C plus H2. C is O, H is 1, O is 16. So this is 90, 12 plus 2 times 1 is 2. O is 16. This is 90 over 30. That is 3. N is 3. So remember, molecular formula is N bracket empirical formula. N is this 3 now, you've calculated. So the molecular formula is 3 times empirical formula. Open it. 3 times C times, so times here, only 1 times 2 here, 3, that is 3 6. O, the one here is 3. So this is the um, molecular formula, which is number 8. Of hydrocarbon, the molecular of the carbon is it an alkane? It's a hydrocarbon, meaning carbon and hydrogen, CH. We were given the mass of hydrogen. Now they want you to get, they didn't give you the mass of the carbon, but you were given the molecular weight as before. Like saying C, X, H, CX, and H. We don't know the mole for the carbon, but for the hydrogen, we're not giving the mass. For the amount in the moles or amount in moles for each of them first. That's what we are looking at. So since we are, you know that amount in mole is mass, molar mass, which is N. Amount in mole is mass or molar mass. We're given hydrogen, so amount in mole, which is for hydrogen, which will be 6 over. So everything is 6. So at the end of the day, you are getting 6. We don't know C. That's why I call it X. We're given H6. So next thing you have to equate this formula to the molecular weight or molecular mass, which is CXH6 equals to 54. Then you split this. This is something as CS plus H equals to 54. Then remember, hydrogen is 1, carbon is 12. This is like saying 12 times X, 12X. 1 times 6, 6, also 54. This is normal mass. Collect the one that are common. So this one has to come here. 12x equals to 54. When this comes here, it jumps to minus 12s equals to, add this one, you get 48. S equals to 48 over 12. X will be equals to 4. Since x is 4, I will now put it into this compound so that I will know the formula of this compound. This is C4H6. So this is not the formula. But we have to find out whether it is an alkane, alkene, or alkyne. So if you know how to write organic compounds under organic chemistry, so you should know that C4H4 is like this. One, two, three. This is 1, 1, 1. Let me draw it again. Let me make it clearer. As H. 1, 2, 3, 4. C4. 1, 2, 3, 4, 5, 6. So you see this group. Alkyne. Answer. D. Alkyne. C4, H6. Triple bond. Number 9. A certain hydrocarbon, a certain hydrogen on complete combustion at STP produce 89.6 km³ of CO2 and 54 grams of water. The hydrocarbon should be, so remember hydrocarbon, that they are mentioning hydrocarbon, carbon and hydrogen. But take note, in this question, we are more interested in the carbon and hydrogen because they say hydrocarbon. But give you a compound that has carbon and a compound that has hydrogen. So we are interested in this carbon in this compound, and we're interested in hydrogen in H2O. But instead, they are giving you the volume of this CO2 as at STP, you should know what that means, as 89.6, while they are giving you of water as 54. But remember, there's hydrogen present in water. We're interested in that hydrogen. While there's carbon present in carbon dioxide, we're interested in the carbon. So we have to use some formulas here. Molar volume of gas, N is equals to the molar volume of gas, 22. So we want to calculate the amount in moles. That's the first thing we have to do for carbon in CO2. So we have to use this formula for this one. We use another formula for this one. So molar volume of gas is 89.6. This 22.4 is a constant value. Down to climate, it's constant value. So 89.6 over 22.4. So divide that, you get 4. So this 4 is the number of moles of carbon. That is this 4. So we are done with carbon. Let's go for hydrogen. Remember, the hydrogen present in water. But in this case, we are giving 54 grams of water. This is for carbon in CO2. So we want to do hydrogen in H2O. But for this hydrogen H2O, we are only giving 54 grams of water. So the first thing we have to do, you have to calculate the amount in mole of the hydrogen in the water. And know that amount in mole is also equals to mass over molar mass. The mass is 54. The molar mass is 18. Remember, we are calculating the molar mass of the water. The amount in mole of the water, I mean. That means the mass over molar mass. Water is H2O. So this is 16 plus 2 times 1 is 2. That is 18. Everything should be that's that's 3. So the amount in moles of hydrogen of water is 3. But we are interested in the hydrogen in the water. Since we have calculated the number of moles of hydrogen in water, that means we have calculated the one for hydrogen. But because of this in water, we multiply this by 2. We multiply 3 by 2, 3 times 2. What you get will be the amount in moles or the number of moles of hydrogen, which is equal to 6. So your answer will be C for H6. The C4 is the one we calculated first. Then the H6 is the one calculated here. Remember, when you divide this, you get 3. But because of this 2 in hydrogen, you have to multiply what you get by 2. So that your answer will be 6. So your final answer is C for H6. A sample of substance containing only carbon and hydrogen burned in excess oxygen to yield 4.4 grams of CO2 and 2.7 grams of H2O. The empirical formula of the substance is okay. So this question, remember, just like the previous questions, it's just like the previous question. We were given 4.4 grams of CO2, but we're interested in the carbon. So what we have to do, we have to calculate the amount in mole for CO2, the amount in mole for H2O. Then what we get, because of this 2, we multiply by 2. But for this one, we use it directly. So we'll start like this. Let's solve for carbon in CO2. This information we're given 4.4 grams of carbon. I know that N equals to amount in mole is mass over molar mass. Mass is 4. Molar mass of CO2. CO2. That's C is 12. That's 12. O is 16. 16 times 2. That's 32. Then 32 plus 12, you are getting 44. So divide by 44. When you do this, you get 0.1. That's for carbon. Then let's move to hydrogen in H2O. The first thing to do, you have to calculate the mole, which is mass 2.7 gram over molar mass. That's H2O. H is 1, 2 times 1, 2. O is 16, 16 plus 2, 18. When you divide this, you get 0.15. Like the previous question, because of this 2 here in this hydrogen, in this water, because of this 2, I have to multiply this value by 2. When you do this, you are getting 0.3. 0.3. So carbon and hydrogen now. C is 0.1. H is 0.3. When you have something like this, well, you can, in order to make it whole number, you can multiply by 10, or if you say by the smallest, which is 0.1, you will be doing the same thing. 0.1. this is 1, this is 3. So your answer is CH3. The last question, this one is a little bit complex. Let's divide this. Okay. 25 cm cube of 0.02 molar KOH neutralizes 0.03 gram of a monobasic organic acid having the general formula, which is this. The molecular formula of the acid is, the molecular formula of the acid is, given its formation. So, in this kind of question, the first thing we have to do, we have to calculate the molecular mass. Then, for the molecular mass, we have to equate this molecular formula to molecular mass so that we can calculate this n. After calculating n, we have to put it back into this formula to get the actual formula, the molecular formula we are interested in. That's what we are going to do. First of all, calculate the molecular mass. And there are formulas for it. We are giving volume, we are giving the molar concentration, we are giving mass. So we can calculate the molecular mass. Molecular mass is equal to mass concentration over molar concentration. That's the formula for molecular mass. So what I need to do is, the molar concentration is 0.02. I have to calculate the mass concentration. After that, I will put it into this equation so I can calculate molar mass. So mass concentration is like this. Mass concentration is mass over volume times 1000. Mass over volume times 1 dm cube. That is 1000 cm cube. So the mass is this. Sorry, the mass is this. Volume is this. So I can calculate this now. So the mass is 0.03 over 25 times 1000. So when you multiply all that, you will get 1.2 gram per dm cube. So since I've calculated the mass concentration, can I put this value here so I calculate the molar mass? Remember, we know the molar concentration as 0.2. So the molar mass is equal to mass concentration 1.2 over molar concentration 0.0. When you divide it, you will get 60. This is not the molar mass. So this is to equate this general formula by 60 to 60 so that I can calculate n. I can calculate n. So this is like saying CnH2n plus 1 COOH equals to 60. So here you have to be careful so that you don't make mistake. Remember, hydrogen is 1, oxygen is 16, carbon is 12. So I'm going to put all those values now. But first of all, let me split everything. This is like saying Cn plus H2n plus 1 plus CO plus O plus 60. Remember, H is 1, O is 16, C is 12, right? If C is 12, this is like saying 12n plus, remember, H is 1, 2n times 1 is 2n plus 1 plus 12 plus 16 plus 16 plus 1 equals to 60. So for we'll add everything. Remember, those are common. N. This one that don't have n, I have to put that side. When you add everything together, this is like saying 12n plus 2n is 14n. They are common. The one that is common will add up. The one that is not common will meet the one that is common. So 16 plus 16 plus 1 plus 12 plus 1, everything is 46. That is equal to 60. So from here, you know what to do. That's 14n equals to 60 minus 46. That's 14n equals to 60. That's 14 also. So n equals to 14. N equals to 1. So n is 1. That's not the end of the question. The last part of the question now. Since n is 1, I want to put n into the general formula so that I can get the actual molecular formula. What it means is that anywhere I have n, I will put 1. So that I will not check if at the end of the day the formula is any of these options. So that is the next step I want to do. Anywhere I have n, I will put 1. This one will be here and here. So let me use. Okay, remember, the last step is to put this n I've calculated as 1. I want to put it here and here so that I can get the actual molecular formula. So this is CnH2n plus 1 COOH. So I put n here. This is like saying C1, but we don't put C1. We just put C. So this will be C. Two, 1, 3. CH3 then OOH. You can see that this is the formula CH3COOH. This is C. This is ethanoic acid. So that's your answer. So for this molecular and empirical formula, depending on the question you are given, the different question can be given. That will determine the kind of approach you will give to it. If it's the one involving vapor density, there's formula for that. If it's something like this that is complex, you have to use all those formula: mass concentration, molar concentration, amount in moles, molar volume of gas. That will determine the formula you have to use. So that's the end of the video. As usual, if you enjoy it, you can leave a like and subscribe. Thank you.